I just briefly want to make a video describing the solution to Project 2, in case some of you were interested. So there's Gallup's article, right? Most of you found that there's some population proportion. We're going to assume that's 0.45, so 45% of the population have tried marijuana at some point. This is our population proportion. And I said what it means in words. P hat, that is our sample proportion, right? That's from our class. That was 23 students said that they had smoked marijuana, and you hear the difference there, right? Smoked versus trying. 23 students said they had smoked marijuana out of the 42 that took the survey from the class. That gave us this sample proportion, right? Then we have our standard error. And our standard error is calculated in the normal way. We take our population proportion, which is this number, times the complement of it, 1 minus this number, right, divided by 42. Notice our standard error doesn't have this number in it at all. Our null hypothesis is that, let me type it out, I'll type it out. All right, so I just typed out what these things mean. The null hypothesis, right, we were saying the proportion of people in Massachusetts who have tried marijuana is 0.45. Notice this doesn't have anything to do with the United States anymore. We already know that 0.45 represents the United States and how, like, the proportion of people who have tried marijuana in all of the United States. We just want to know if it's the same or if it's different. So the alternative hypothesis is the proportion of people in Mass who have tried marijuana is different from 0.45. Right? Obviously, it looks different here. It looks like this is 0.55, but this was only one sample, so we want to know is this sample statistically significant? And so we do our test. Our alpha is 0.05, and we do our test statistic, which is just a z-score, right? So it's p hat minus p over the standard error. So that's that. And then our critical number, you don't actually need this, but some people chose to compare the critical number to the test statistic instead of finding a p-value, which is fine because they work the same way. So if you got your critical number, this is your critical number for a 5% level. 5% level or alpha 0.05. And our p-value, a lot of people got this. You basically, let's do all the steps here, right? If we delete that, let's go ahead and do that. So here's what seems to be our p-value, but remember, we want this to be the right-hand side, so we're going to go ahead and do 1 minus that. And then we have to double this because it's a two-tailed test. So I'm going to just do 2 times that. And I'll put another parenthesis over here. And so our p-value is huge. It's like 20%. So we compare p-value to alpha, and I'll type it here. P-value is greater than alpha. So that means we're going to fail to reject the null hypothesis. So we're going to say, oh, it's possible that the proportion of people who have tried marijuana in Western Mass is 0.45. And we remember 0.45 is the same as the United States, so the proportions are the same in the US and Mass. That's what we are saying because we have failed to reject the null hypothesis. It's possible we made a type 2 error and that this is actually incorrect, that it's actually a different number that's different than 0.45, but we can't know if we made a type 2 error until we do like another study. All right, so that's it for the solution to Project 2. There's another way to do Project 2. Let me pull up the page and maybe I'll make another video on that. A couple students chose to do a difference of 2 proportions for Project 2, which is actually totally fine. You just have a different null hypothesis and a different alternative hypothesis. We are saying we have 2 samples. One's a sample from the United States, which is fine, which is actually what it is. And then one is a sample from Western Mass, right? And so maybe I'll make another video doing Project 2 as a difference of 2 proportions as opposed to the way we just did it. All right.